Hi everyone. As I mentioned, it's our final presentation of this section of the day before we head into a little break and the round tables. So I wanted to introduce Afshin and Lars, both from Siemens Gamesa Renewable Energy. They have a presentation and a live demonstration that I think is going to be fantastic. It's going to give you an example of everything that we've come in today, using all the data, all the predictive stuff that we've been talking about, all the material stuff, and how you can actually prevent future failure through innovation. So you want to get straight into them. So I'll hand over to them. But just a reminder again, if you've got any questions that come up throughout the session, pop them in the Q&A box and we'll do the Q&A afterwards. So Afshin, over to you.
Thank you, and welcome to Blades Global 2021. Thanks, Alex, for the brief introduction. My name is Afshin Taffazoli, the Sales Enablement sitting in Global Sales and Marketing, and my colleague Lars Nielsen, the Chief Engineer from Global R&D. I start with the presentation and then I pass it on to Lars in the next round. So today we're going to talk about visual-based asset integrity, VBAI, and blade integrity management, BIM. I start off with a quick introduction and motivation on the benefits of VBAI and BIM. Then Lars is going to take you through, walk you through the SGRE innovation and our platform, and then we have an open discussion and QA at the end. So the value proposition, and some background and motivation. The VBAI platform, the visual-based asset integrity, is getting motivated and started, the development from a few years ago in SGRE. And the reason behind it was basically the number of blades across the globe that you're dealing with and operating. Right now, we have more than 1 million blades across the globe. And we decided then, at least the portion that we are operating, we have them all those blades data in a single platform named VBAI. It's a web-based digital platform, accessible from anywhere, 24 hours, 7 days a week. And it's multi-brand, meaning that all turbine types and models can be uploaded to this platform. What is very important is the inspection image and metadata quality requirements. So basically the garbage in, garbage out. We want to make sure that we stick anybody who does the inspection, stick to a minimum requirements, and we validate inspection vendors through our program. We also have blade expertise and also artificial intelligence working together to be predictive and also fast and precise. And then we have also BIM inspection and BIM R&M programs that could complete this loop in terms of accommodating the needs on the blades, and whether there are some upgrades required, that can be addressed as well. So providing an end-to-end service solution here, we want to make better and more efficient blade management decisions. It forms part of the complete ecosystem of a blade care solution. And the ecosystem here, as you would see, starts with the inspection. The data and images would be uploaded to our VBAI platform. On the front end, you would see all those modules that Lars is going to take you through. And on the back end, all our AI and engineering expertise that would help to surface all the results in the platform. And then we also combine that in the next level with our BIM products, BIM I as inspection and BIM R&M as repair and maintenance. So it's to precisely determine the health of the blade together with actionable advice. And it's to secure wind farm performance and asset integrity over the lifetime. So how are we different in SGRE? In Siemens Gamesa provides a complete service that goes beyond just inspection and platform. So a typical inspection vendor would offer an inspection and also a platform where you can surface the results. As if in our cases, we have up to 20 different modules and features that you can transparently look into each of those based on your scope and requirements, whether it's inspection vendor, inspection planner, stitching tool, AI annotation, and then the results. And from then on, going towards the code module, budget module, repair module, and if needed, engineering assessment in the way. And everything would be also not limited to the blades. In future, we want to actually have every images be uploaded to this platform, including the internal images from the blade inspections, and also gearbox and other major components. So let's show you what we have created. And please, Lars, the floor is yours. You can take them through the innovation.
Yeah, thank you, everyone. And my name is Lars Nielsen. I've been in Siemens Gamesa for the last 16 years. And when Berit Klug says that she would like something, I'm the tech guy that she places the order at. So if we look at it kind of high level, then you can say we have the wind turbines. If you look at the first green dot, then we inspect the blades, of course. And we inspect the blades on the outside and the inside. And in this case, there's a drone, but like Berit said, we're also looking into other technologies where we might, does not need to stop the turbines additional, so we could do it during the annual maintenance. And then we took some decisions back in 15. We actually started inspection in Siemens Gamesa, and actually until the last year, there's always been kind of like, should we do this ourselves or should we just use, the vendors' platforms? But then a decision was taken that we wanted to do this and have it part of our blade integrity management. Maybe just to support Afshin on that one. When I say blade integrity management, a lot of our customers, they buy up to 30-year maintenance programs on their blades. So we take the liability and all the repairs on the blade for up to 30 years or end of life, basically. So we store all the images in the cloud. We've had a strategic collaboration running with Microsoft. So it's a little bit like when you have Windows on your computer, you can say if you have data in this database, it's like Microsoft doesn't look in my email or my Excel and what I do, but I use their software as a solution, basically. Then we do a lot of analytics. This was discussed between Berit and those guys, and we are actually pretty far with that part. And yes, we can predict how blades fail or develop or evolve in the field. And then, of course, we do the result and reporting. You can always go on the online portal, do PDFs and so on, but the most important thing is actually what to do about it. And there, of course, Berit wants it in her ERP system. So we're integrating to SAP and basically giving and telling her sites through work orders and notifications what to do and when to do, so they can basically schedule and then perform the repairs and the parts on that part. Next one, Afshin. Mm-hmm. So what we did was kind of do a portal, because we have turbines all over the world. And for example, we would have a site lead in Chile, we would have a guy in Croatia, and we would have maybe a guy in Norway, and they all want to inspect their blades. And basically, I said in Brande, we don't want to be involved in that. So if I take you kind of from the top on these applications, then we have all our vendors in the platform here. And if we have these BIM clients, then basically they have access to this, but we do all the work for them. While we have other clients, they want to do everything themselves, and they basically use this, like I have Windows on my machine, and I basically don't interfere, but they just use the system, and you can say that the power of the system. So we have, you can say, requirements to all the vendors around their data to get good quality in, like Afshin said, and those vendors, they have then been validated on the vendor check list there. Then it's possible to find those vendors and basically see, like you go into a restaurant with smileys, how are they actually performing and what can you inspect, and they know how to upload the data into the platform. The next module is what we call the planning module. So in here, it's possible to plan the inspections, execute the inspections. And here we actually have some of the first AI sitting, because we do some quality checks with algorithms on the data coming in. Like, is the whole surface of the blade covered? How is the metadata? Is there blur and contrast issues? Then we take the pictures into the next one, which is our stitching. If everything is perfect, we actually don't open that module. but sometimes we need to open it because there is some issues with the metadata. But that's basically where we stitch the pictures together, and we do that because we don't want to do double counting, and we want to know exactly where the distance is to the root. And we have a pain on the drones because they always have some inaccuracy on where they are, which is troublesome for our engineers. So yeah. Then what happens next is that the data is basically taken through some algorithms also sitting in the Azure cloud. And we took a quite different approach, I would say, because I basically said to the AI people, I don't want you to train on what we can see on the blades. I want you to train on what is different from a white surface, because I also want to detect the unknown. So what basically happens in there, of course, we have the segregation algorithms that segregate, sea, air, what is nacelle and what is blade. And then we basically detect down to pixel level what is different from white. And then we basically tell that. And like it was said in one of the other forums, then we also give them like these levels 0 to 5. And all the 4s and 5, and it depends on the clients actually. Some want their trees to go to the engineers, but they then go to engineering assessment, which is kind of the next module. So customers or our clients using the system, they have access and can choose what data, what pictures they want run by our engineers to have an assessment done. How critical is this? Can I let it run or can I not let it run? So we annotate and have the human review that like the guy from Susla said, we went away from humans doing everything, so they review what is necessary. And then comes what I call the predictive tool. So we actually took all the data we have back from 15, and then we fed it with the age of the turbine, the rainfall, and we have had consistency in our annotations since 2015. And this year alone, we're actually inspecting 10,000 turbines. So this year alone, we'll have data from 30,000 blades. But we basically fed that into what is called a Bayesian network, which is a neural network. And then we took one side, and then we didn't train that one, or we didn't even tell the system what it was. And then basically we can hit the accuracy of how turbines will look like in the future, and also how they look like without inspecting them with more than 90% accuracy. So that is kind of you can say we do the AI up on the annotation module simply to bring down the cost and the time and the efficiency, so we can deliver these reports within 24 hours. But we also use it down on the predictive part, where we basically, if someone asks me, how does the erosion look like on this site that we're offering a BIM contract on in Paraguay or Chile or whatever, then I can basically go in and type all of that in. So it is possible to predict that part, and it's a quite cool thing we ran with Aalborg University, and we actually ended up hiring the people who did their master thesis for us on this one, and actually made it work and computed in the cloud. The next one is what we call the data analytics. We choose to use something called Kibana. So we have indexed the whole platform. So you can say clients who have their data in there can also do quite advanced analytics if they don't want to use the up and download center and just take the data out and use it in Excel. And then we have the platform, which I think most people know how to. You go in and you navigate and you can filter and all that stuff. And there in there we can actually see the failure propagation, because we can compare blades, how they are inspected year over year, and then see how the failures are propagating. Then because we also do a lot of repairs, so basically the data that would need repair from you can say the portal, it's possible to take those into a quote module, and then we can do online quoting and invite bidders in to repair. And those clients who use the platforms, actually sometimes they don't invite Siemens Gamesa to quote on the repair, and sometimes they do. And then they take it into their budget module where they basically monitor the repair. And those people who then is selected to do the repair, they actually have access to this platform and can go into the repair module, where it's possible then to check off that the blade is repaired. And it, for example, we have when we repair with UV, then we have some requirements of the pictures, and and time that the materials is exposed to the UV. So data and movie clips and everything can then be uploaded associated with the repair, so we can go in and check that part afterwards. And then we had another client who said, couldn't we, instead of doing all these Excel spreadsheet exchanges of you can say during the warranty settlement, couldn't we just do that in the portal? So a part of this we also did with Microsoft around the security was to do what we call the warranty module, where it's possible then to filter what a client want to claim, and then basically invite the OEM in to kind of settle the technical part, and that's where standardization was talked about. Also, I listened into some of the earlier ones, so we can actually do translations in this system, and we use one standard to annotate our blades, and if a client uses another one, it's possible to set up one's own standards. And then we've had troubles over time getting our data back from various platforms. So one of the mantras on this system was to have an up and download center where we don't manipulate, change, or delete any data. So any raw data on the system can always be fetched out of the Asia stack and taken in. And then, like Berit said, we are not only looking at the outside of the blade. This year, I am getting data from 5,000 turbines on the inside of the blade. So we have a module actually also where we do the inside. And when Afshin says that we're looking into gearboxes and stuff like that, we are actually starting on, if some of you know what RDSPP is, so that means that you can cover and take pictures anywhere in a power plant and basically store it in a database like this and do assessment, no matter if it's gearboxes, lifters, or something out offshore. Yes, can you take the next slide, Afshin? So this is just a little bit into the platform. Of course, if you look at the top picture, this is it from the annotation module where you'll see some red stuff, and that's actually where we control by using the algorithm and the math from the metadata coming in, how is the overlap of the pictures, so we don't do double counting. And the AI basically show us what is detected. And then we can annotate and do all of that and have the human review. And below that one is kind of a sneak into the portal where you could do all sorts of filtering and, of course, look at your blades. And then there's a snapshot in the middle of the cabana where you can do these heat maps to kind of see in park or even on your fleet level, how is it actually looking like. So we look at it a little bit like a PDCA thing, like you inspect and annotate, and then you monitor a blade, and then you do some re-inspection and monitoring, and then you decide what you want to repair, and sometimes you also want to upgrade. Can you do the next one, Afshin? So just to give a little bit, I also participated in the erosion forum today. So since 2015, we've been very consistent on what we actually call things and the severity level. So that means that I can really train on the data and have my data scientists, they are very happy. And you can say, we talked about it earlier today in that forum, that you can say as soon as you're into the fiber, do you then need to repair? So for example, if you take out to the right here, then you have the top coat, the filler, and the first and the second biax. Sometimes you can actually be into the leading edge, you can say fibers, and then just put some filler on and put on, for example, a power shell, and then you don't need to do the structural repairs. It's first when you actually hit what is called the UD layers that you might need to do the repairs. But this is basically, so everything is classified as to, what is it? Is it pinholes or cracks? And then it gets a severity level. Can you do the next one, Afshin? Then going back to the leading edge erosion and the prediction. So I can ask the Bayesian tool, how would this turbine somewhere in the world look like when I know the tip speed and I know how old it is and so forth and what paint it has. But it's also possible, I think Polytech showed it very well with the rain erosion test. And there are some pretty sophisticated MATLAB models behind it. So this is an example where, for example, we have carboline on a blade, and then we have what we call a wet LEP, and then we have what is called CARE, which is our shell sitting on the tip. So it's actually possible for us, from a theoretical point of view, to simulate this. And a lot of you is talking about it. That happens in all sales contracts, more or less. You sit down with the client, you basically run it through this simulation, and you have a dialogue about what LEPs would fit this park where it's situated in the world compared to the capex. That means the investment in the leading edge in the beginning, and some leading edges also come with an AEP loss. So in this case, you can see there's 3 LEPs on this blade here. There's one from 55 to the edge where there's sitting a care shell which will never wear out in the 30-year life. Then there's sitting something from 40 to around 52 meters, which would need a repair at a certain time, because you can see it goes from the blue up into the red. And then there's a third, which is basically just a normal paint that would also need a repair. And then you basically sit and do these simulations here. So it is, I would say, on newer blades, you can say manufactured within the last 10 years, it is possible to simulate and actually tell how those blades would look like from an erosion perspective. It is not a surprise anymore. And I would also say the materials and the cures are existing. It's just a matter of getting it, deciding on what needs to be mounted to kind of solve the problem, depending on the age and remaining lifetime of the turbine. Yes, Afshin, can you take the next one? So I did this curve a while ago to kind of explain people, because we had a lot of clients who said, I want all my trees repaired. And you can say I had a boss who said, I never want to exchange an offshore blade, Lars. So if you look out to the right, these are kind of estimates. We also talked about larger blade and what does that impact. So the price of changing blades, like if you take the G2 out there, that's our 2.3 megawatt or 2 megawatt. But then if you take the new larger blade offshore, then you're talking more than €1 million to change a blade. So what I usually tell all the salespeople and so on, we want to react on a 5. We potentially want to stop the turbine because we want to do a repair, and that repair is much cheaper than exchanging a blade. If we see a category 4, then we might want to look at it like the guy said from RWE, I think it was. Is it actually progressing, or could this one run, and could it run until the next repair campaign? So we typically have what we call the asset integrity line, where is it moving towards 5, and then we need to do something, and when do we need to do something? And then you can say what I call on the right side of the asset, or left side of the asset integrity line, the green dots, is that they can be repaired. There's probably going to be some small chipping paint here and there, but it really doesn't affect the performance of the blade. And you could spend a lot of money doing these repairs, but you will not get any structural health or even production gains from it. So it's a matter of, how do you want to spend your money? And I think that's where we have the dialogue with B8 around that one about, how do we spend the money best? And what really needs fast attention. So Afshin, can you take the next one? So what we basically do is that also on the platform is that when it has been given, what is it and what is the severity level, then we have what we call the response level, which is kind of the standard response that we have agreed with our engineering department. Or they basically say, because they say what the severity level is compared to the specific blade, if it's a Senvion, a Siemens or Vestas or whoever. And then they basically go in and then we give it this, is it an RM1 and RM2? Do we want to monitor it, or is it just a non-critical finding that has a cosmetic value? So that's basically how you can say the whole process in the platform is automated by having the standards and the consistency in place, basically. Yes, I think that if you take the next one, and it's you, Afshin.
Yeah. So thanks, Lars. I think based on all this explanation and the customers' requirements and the scope that we want to include in our product offering, we can of course provide access to all the modules in the VBAI, Visual Basic Asset Integrity, if they buy into a complete package as BIM, BIM RNM or BIM I. Of course, if they buy into Beam R&M, we take care of all the repairs, and so they don't need really have to have coach module or budget module activated. The same for Beam I, we are responsible for inspection, so the inspection vendors we're going to select, so they don't need also to have that access. So, but again, that's like a premium product we're talking about, Beam. And if we talk about standalone VBAI packages, we have a complete package where they can get access to the core modules, but then have to pay extra credits to get engineering assessment, human Q&A, composite specialist, or data analytics tool, the premium one included in the package. Again, if they want to go even cheaper and they want to do their own inspections with the vendors that has been approved by SGRE, then they can also go to the next level. Of course, the price would be lower, but then they can decide whether they want to do the AI annotation or they want to pay extra credits for SGRE to do that. And if, of course, they want to do ad hoc inspection with SGRE, that we can also provide even more reduced package in terms of cost. Again, there are very small costs related to the storage, and we have two models, whether they want to buy a chunk of storage and then renew it when they're finished with that storage, or they can pay as they go, and we charge them on a monthly basis. Again, to wrap up, your advantage of partnering with SGRE is a lifetime blade health by combining machine learning capabilities, unique knowledge and expertise, and we shape the future for blade care management. It's access to unique experience. So we have experience of inspecting more than 50,000 blades and more than 20 years of registering blade inspection data. And again, it's scalable in future. So today we are focusing on blade inspection data, but tomorrow we will include all other inspection that use image captures from internals of the blades or gearbox inspection and so forth. Again, we can move on to the Q&A, but just for those who register for this forum, we decided actually to, during this 3 months of access to these videos, that you get also a 90-day trial for free. And also this access, depending on how many data inspection data you upload to the system, would basically end after that 28 years from the day you start uploading your data. Again, we make sure that we provide you with technical orientation meetings and have bi-weekly calls to answer all the questions. And of course, after the trial, you determine the preferred scope, as I showed you, different packages, the features, storage, credits, and extra services that you want to buy into, and we can provide you with a proposal at any time. Again, please reach out to me, Afshin Taffazoli, or your service sales account manager to move forward with this offer. Thank you.
Thank you so much, Lars and Afshin. And the notes on how to reach out to Afshin, either through the app, or you can see his email on the slides, which we'll upload later, but we'll also include that in the thank you email. So anyone who wants to reach out to take advantage of that exclusive trial is able to do. Now, I'm conscious of time. We have the roundtable starting in about 15 minutes, and I want to give people a chance to grab a quick water or coffee, depending on their time zone. But we do have quite a few questions coming in. So shall we start off with, how reliable is an extrapolation from the experience in VBAI to new blade designs, 100 plus meters? With longer blades, potential failure modes and manufacturing can be significantly different. Lars, Afshin, who would prefer to take that question?
I think
I can do that.
Answer, yeah, please.
Yeah. So if you look at new blades, because we don't have any data, they haven't been out run yet, then basically what we can do is say, okay, this is the same paint as, for example, let's say we have the B108 and we had the B100. So what we can say is, okay, we know how the failures were propagating on the paint on the surface of, for example, a 100. So then you can extrapolate it to some point to an 108. But for example, especially on the paint, the leading edge, you know your tip speed and all that stuff, that can be simulated. And you know how, for example, on the blades you produced 3 years ago, how are they actually performing in the field? So you cannot tell exactly how a 108 would react, but we have a pretty good idea because we are not, like Stigsdal said, we are not inventing blades from scratch. We are building on the learnings from the last blade all the time, because no one would dare to set a brand new blade offshore. I think I would never experience that you would hire an unexperienced company to design your new offshore blade and then send it out there and take the risk on it. That would be too dangerous. Yeah.
What tools would you recommend using for internal inspection of the 5,000 blades you mentioned?
Currently, we actually use something as simple as an iPad, where we have an app to inspect the root end, where the technician just go in with an iPad and take some pretty nice pictures, which we can easily access in the background. Then we've been trying flying inside the blade. It actually works when the blades are quite big, but when we get into and the air gets a little bit narrow, we can't control them. So my best suggestion is something that drives on the surface because and is not very high. Then you can actually get pretty deep into the blades. It is what we use in the factories actually, but there's a cable in the back and not to reveal too much, but we are working, like Berit said, on small, you can say, autonomous driving vehicles that can find their own way inside the blades. Yeah.
Wow.
Actually, with a UK company, I can hear in your accent that you come from there. So
I am a Londoner, but that doesn't mean I'm biased against that. Blades Global, so pro everyone here. Some damages on two different constructed blades look the same from outside. How do you consider different blade constructions? So they put in brackets integrity blade versus conventional shell construction in the decision for further repair or monitoring steps. Are the results for each blade construction equally reliable? That's quite a long, complex, got lots of parts in that. I hope.
So we react differently, like Berit and the other guy said, compared to which blade it is. So, for example, there was also the question about IR. Yeah, we have been using IR a little bit at one point because you can really find if there's a huge, big missing glue joint, but you cannot find the small stuff. Then we need to use active heat on the blade and then IR. Then you can also find the small spots. And there is a quite difference between, for example, our integral blades and the Gamesa blades and the LM blades on what can operate and what cannot operate. And we actually often see that when we send the data in, then the technicians, they want to know where a crack is down to 20 centimeters, because they need to know how the glass layup is in order to determine if the blade can actually continue production or not. And that's actually why you can say part of the platform is that we offer the clients to have the dialogue with the engineers and also on the repair part. Because on those structural repairs, you really need to know how the glass layup is. Otherwise, when you grind down and build up the glass again, you might be causing more good than, or more bad than good if you don't have that under control. Yeah.
Just an addition on this, we can also in the platform program different response mode and different, let's say, BCS categorization based on what has been agreed with the customer. So it's flexible. And of course, we have different BCS for integral and butterfly blades, and that's been programmed into the algorithm of the platform so that all the annotation would be done according to those blade condition specification, depending on what blades we're talking about.
Yeah, so let's say one customer says that these cracks category 4, I only consider them 3, and I want this response level that we program into the platform. So compared to different appetite, we also deliver different answer compared to how they want it. Yeah,
that's really interesting. Being able to speak those different languages and set those different standards.
Yeah, and it is a commercial thing. It is actually a very commercial thing because it's the appetite of paying for the fast mobilization and the repairs, where some is willing to pay for that and some say, no, I can live with that risk. So, yeah. Okay, sorry.
No problem at all. I was just going to end on one quick question, and then we'll head over for everyone grab a break before the round tables. I'm pretty sure I know the answer to this, but is the VBAI platform also used to predict damages on blades not manufactured by Siemens Gamesa?
Yes, we use it for all blades, GLM, everything that is in there. And we have what we call an ecosystem, because of course there is some, you can say we have some NDAs and stuff. So for example, if we have a client, we have big clients who share all their data. So you can use the predictive tool, but you cannot see, for example, how an Ørsted site was producing in the UK. But we use it as big data where everyone gathers, or you can say like Birgit was saying at one point, couldn't we do some more sharing? So that was one of the things we really had in the development of this one, was saying, of course, we don't want to share these details, but we all want to learn from how the blades are propagating. Yeah. So you can say when you share data on the platforms, they are anonymized. And used in big data sets.
I like the way you put it in the presentation, where it's like using Excel. You can't see the data that's in there, but the formulas work the same, and the processing. Yeah. Perfect. I really appreciate you both giving us a fantastic insight into an amazing innovation that I think captures what a lot of people are looking for at the moment. So thank you so much for taking the time. For everyone watching, as I mentioned, we've got the roundtables in about 10 minutes time. So grab a water, grab a coffee, and we'll see you joining on those. Just to make sure, because when we had the roundtables earlier, if you had an issue joining one, it might be that you just need to give it a second to make sure that you're connected to your video and your audio. And they are limited, so it is a first come, first serve. So if you have had a chance to be a part of the Leading Edge Erosion table earlier, then do give a chance to other people joining this afternoon. Otherwise, have a lovely afternoon, evening, or morning, depending on where you are. Thank you.
Thank you, everyone.
Thank you, Alex. Thank you.
Bye-bye.